Hello, I'm Officer Nights the Nightmaren. We will learn about cumulative probability distribution. A cumulative distribution function, CDF, of a real-valued random variable uppercase x, or just distribution function of x, evaluated at lowercase x, is the probability that upper x will take a value less than or equal to lower x. In the case of a scalar continuous distribution, it gives the area under the probability density function from -infinity to x. Cumulative distribution functions are also used to specify the distribution of multivariate random variables. Note that its formula is given by fx of x equals p of x is less than or equal to x, where the right-hand side represents the probability that the random variable x takes on a value less than or equal to x. The probability of x lies in the semi-closed interval, a less than b is p of a less than x, and x is less than or equal to b, equals fx of b minus fx of a. You know, every cumulative distribution function is non-decreasing and right continuous function. We can now use the integration method, typically it's advanced mathematics. Now, the integration type is the definite ones from a to b fx of x dx. Like Sonic taught about the integration function. Let's see the following cases. If x is uniformly distributed, which is at the interval which takes only the discrete values with equal probability, like 0 and 1, 1 and 2, 2 and 3, and so on. If you like to take the interval 0 and 1, that means x should lie in the range from 0 to 1. If x is exponentially distributed, then you'll notice a lot of various curves, like y equals 1 by x, x squared, x cubed and others. If x is normal, or binomially distributed, just like we talked about many ways of rolling a die or tossing a fair coin, we see a bell curve. So far, when you keep increasing possibilities, we will see a bell curve that becomes closer to normal distribution curve. So, this is how the probability of cumulative distribution works. Like, comment, and subscribe now on YouTube.